אז הפעם שיש פה אנשים מעולם הבנייה ולא רק מעולם התכנון וגם מעולם הסטארט-אפים, זה מאוד מאוד מרגש אותנו. ואני באמת מאוד נרגשת שהגענו עד הלום. תכף אני אציג את השותפה שלי גלית ואת השותפים האחרים גם. אבל קודם כל, אנחנו בית ליבלינג, אנחנו בית לעירוניות, לאדריכלות, לשימור. אנחנו שיתוף פעולה של עיריית תל אביב וממשלת גרמניה. השותפים שלנו הם בגרמניה, זה אומר שהרבה הפרויקטים שלנו הם בילטרליים, אנחנו מנסים להוות מקור של ידע בתחומי העירוניות והאדריכלות גם פה וגם שם. והמסורת הזאת שעכשיו גלית ואני חונכים פה היא מסורת שתלך ותמשיך איתנו, כי אנחנו לא רק רוצים לדבר על אדריכלות ומה שהיה, כי תל אביב אונסקו והכרזת אונסקו ותל אביב העיר הלבנה וגרמניה וישראל וזה המשותף בינינו, אנחנו רוצים גם לחשוב קדימה יחד איתכם איך אנחנו נבנה בעתיד, במיוחד שכולנו יודעים שבעולם יש יותר ויותר ערים, ובצפי אני חושבת ש-2050 2.5 ביליון אנשים יתווספו לכדור הארץ ויתחילו לגור בערים. אז איך אנחנו גרים בערים? זאת שאלה שמהדהדת כל הזמן מעל ראשנו, במיוחד בחיבור של בינינו לבין כדור הארץ והסביבה והאופן המקיים שבו אנחנו בוחרים לחיות מדי יום. אז under construction, אני אמשיך באנגלית, because we have our German partners with us as well, I hope you can hear us, is not only a term in the building sector. It seems as a collective state of our being since we try to deal with the situations of the 7th of October. So in this sense, it's not enough to rebuild, we must build back better, and this is why we are all here today, in order to find the fusion between the building sector on one hand and its needs and its advantages with technologies today, but on the other hand combine it with security and social issues and of course everything that has to do with sustainability and climate innovation. So in order to overcome both the physical and mental state of our nation today, this is just really a small step to help us maybe imagine how we can do projects, innovating projects, impact projects together in the future. And without further ado, we would like to start this evening, and I would like to introduce Galit, my partner and architect, Galit Chief, and I'm so happy that we made it until today. And she will continue from here.
It's unbelievable, actually, when Sharon and I dreamed this vision of the program. It's already, I think, 2 years, Sharon? Yeah, it's unbelievable. And we felt the need to connect the traditional construction sector with the climate needs, and knowing that construction is the most polluting and most energy demand sector in the climate, we felt there is a need, an urge to bring innovation to this sector and to combine construction with climate tech. We believed that we can and we should help breakthrough startups go to the field and connect them with the market and help them to do a pilot in the site and to find and to show their abilities on the ground. We actually initially thought that it only makes sense to do it in Tel Aviv, the home of the Liebling Haus, and to allow startups to be active in the playground of Tel Aviv. We know that under construction, it's the state of Tel Aviv, here also in the public sector and in the private sector. Everyone is under construction. It's hard to commute. People told me it was hard to get here as well. But at the time, we couldn't even imagine what would happen on October 7. which actually led us to work on pilot program with 4 different sites in the Western Negev, Kibbutzim, Nir Yitzchak, Kerem Shalom, Cholit, and a community neighborhood project led by a Metzudot company. And we are very happy to have you all our partners here. Together, we aim to realize the building back better, which is actually the new Zionism, both in thought and in action. In this context, it's important to say that without the return of our 100 hostages, there is no going back, and our hearts are not whole without them. And at least for the people that sit in this room, we still need to say that if alarms go on, we will go. There is a shelter on the ground underneath. So we hope that won't catch us, but still needed to be said.
So yes, this is a German-Israeli project funded mainly by the German Building Ministry. And it is important for me to say that because I think whoever works in the construction industry today understands that in Israel we build in a certain way. Good or bad, everybody decides for itself, but regulations in Europe are different in terms of sustainability for sure, and in terms of how we want to advance in topics like energy consumption or materiality or circularity. These are all big topics that unfortunately in Israel I think we're not as advanced as in Germany. So here's an opportunity to learn from Germany in that sense on one hand. But on the other hand, I think Israel is, what can we do, known for its startup nation. Maybe today and the time we're now is proving that our ability to be agile and to adapt and to act fast and to be creative. And this is where we can maybe also help the German or the European market to understand some things about how to make fast innovation in startups. So we have a win-win situation, and of course the market in Israel is way too small for startups to really test their cases. This is why the European market is very appealing to a lot of Israeli companies. So this makes the win-win situation even bigger. And I'm debating if I should first introduce the 2 partners that are here, which are very important for us because we couldn't have done it without you, Reality and Desertec. So we will invite you to say a few words as well. But I would also like to introduce the German part. Can we see them? Can we see our German partners? Yes, they're all sitting there. Florian is our partner in, yes, Florian and Kai. They're sitting in Berlin. And, sorry? Yes?
Let's say hello.
And so that you, yes. We will have a lot of options to speak to you later. And just to mention that 5 companies from Israel are going to present really fast pitches and 3 companies from Germany. We will evaluate them together. So you have to be very good listeners because then you have to give their votes, your votes, in order to define the winner. And I'm not going to tell you the prize yet, but it's going to be an amazing prize. And hopefully will get everybody to also do their project really on site. So we also have German partners like the Bau Academy, which is a very important sector in Germany that deals with similar projects like ours, the Founders Institute, which Kai is from, Fineo, and other experts which Florian is going to present later. And Galit, maybe we step onto the program?
Yes. So what have we done till now, and what is waiting for you for today? We launched the program in June as part of the Planetech events, and thank you, Noam, for being here and for the ability to present our program as part of the huge Planetech event. We opened registration and we were very happy to get over 55 applications from Germany and from Israel. And together with our partners, we selected 9 wonderful startups that you will hear about today. Some of them are working on new materials, some on manufacturing, technology. They are very different in their essence and in the stage they are in, but all of them share the vision of creating a change in the field of construction and climate. Key players in the market from here and from Germany in fields such as successful pilot planning, laws and regulation, finance and funding, and work with our great team of mentors. So thank you for the mentors that are here for your great support. You really helped our startups to go forward with the planning of pilots. And today, as Sharon mentioned before, we will hear all the 9 proposals for the pilots. And together with the sites, we will, in the next few weeks, we'll decide which of the pilots will go on ground with the help of the sites. And we are very happy and thankful for the sites for their support in the process. And we are very happy to say that we will really see projects on the ground already at the beginning of hopefully 2025. And Sharon mentioned, you want to tell a little bit about how it's going to work today, or shall we?
Yeah, I think we should just start because we want to hear our, our heroes of the day. So why don't we start pitching?
We maybe just say a few words of thank you.
Yes.
So we don't forget at the end. There is such a huge list. It's just because we had such a great partners to this journey. Sharon also mentioned Sivan Cohen-Shachari and Judith Zilberstein from DCIC, and Chen Rosen and Ophir from Reality. Thank you for your support. I want to thank architect Daphna Shahram from Metzudot, Yael Engelhardt, the architects and people from Nir Yitzhak, Yoni Danieli and Sharon Yoel from Kerem Shalom, Julia Tamin, Aviad Bashari, and Nimi Yofe from Cholit. It was amazing partners from Israel, and Sharon will go on with the list from Germany.
Yes, I think we will do. Florian, could you help me with that in the end, please? And I just want to say, Melina, just to raise your hand. She is the program director of all of this. So just, thanks to Melina, it's all happened. So let's start.
Start with what?
Yes, who's first?
Okay.
Or do you want to say something, Florian and Kai? Maybe you should.
Maybe we should also just say thank you to all the...
We don't see you here in front of us, so I'm so sorry. You're behind us. I completely unsaw you, so I'm so sorry.
No worries. So we just adding up the thank you to the German partners, which is Kai from Founders Institute. You also said that the Bauakademie is here. We just say thank you here for sitting here with us.
Yeah. So we have a second camera over there, so you can look into there and say, hey.
Yeah, exactly. So we can see the crowd here. And Finoa is later not possible. It's not possible to come here today, but we're also having a great thank you. And of course, the mentors which are here. So we use this kind of opportunity to just come together and see each other in person. So yeah, I think for us, great thank you that you're all here. And now we're going to start with the first presentation, I would say. Yes, I think we are curious to hear.
Yes. So Melina, can you just blend in the barcode so everyone can photo it so we can vote? Or how do you want to do that?
I think it's in
After? Okay, so keep in mind that you have to vote, okay? We said that already, so please start.
Good. So take notes on your phone if you want to.
So yeah, we start with the
first. The internet.
So the way we're going to do it is that we're going to We're going to hear 2 pitches in a row, and then we can open the floor for some question here and from Germany. We try to combine it, so we have 1 pitch in most cases from here and 1 pitch from Germany. And the first session we start with V21 from Germany, and then Superpolymer from Israel. Thank you.
Very good. Okay.
Thank you very much for the possibility to present here our idea. I'm here together with Jens, my colleague. I'm Roland. We are from V21. And I think we have a very interesting topic for you today, and also relevant because we are going to talk about increasing the energy efficiency across various industries. But before we go into the topic itself, just have a quick look. Where's now the presentation? Left one? This one, okay. Where's now the next slide? Okay. About who we are. I hope now I don't get any minus points for the rating because the technical problems. However, so the first 2 guys on the left, and then we have 4 other great colleagues and also advisory board. And in the past couple of months, we have been awarded with some nice awards. Just recently, we have been awarded with a Green Startup Award by a German government organization. And another one to mention is, I think, the Seal of Excellence by the European Commission, which we've been awarded during the EIC Accelerator process. And now we're also very proud to be here for the Under Construction Accelerator Program. So, and our mission is basically to bridge the gap between modern living and environmental responsibility with our solution, because in today's world, as we see it, each insulation material has at least one major disadvantage. It might be fossil-based, etc., or you need a lot of material. And also, demand is right now also created by new regulatory pressures or requirements, like in this year published European directive for energy performance of buildings. And now the question is, what is our solution? Our solution is basically the flat thermos flask, which is exactly the same principle, but in a new shape, because now it's flat, and therefore we can use it for much, much more use cases. And just a couple of words on how that works. So I also have, but that's maybe for later. We use really the same principle, which means we have an inside of the panel. I can just show you, but then I go out of the camera. So that's basically here our flat thermos flask. So same principle, it works the same way that we use the vacuum, because vacuum is the best insulation, which is possible. So, and we thought how we can deploy this within the Under Construction program. And we thought that we are going to deploy that one in an example or in a pilot, which is not only changing an important part of a construction site, which is also supported by various European-wide initiatives, which is a climate neutral construction site. And here we're going to talk about the containers. I think everybody knows the pictures of stacked containers where the construction workers are living, not living, but working and maybe also living. And with our solution, we have around about 60% thermal energy savings, which is, I think, quite significant, plus 20% more living space, which is also in this little segment, how do you say, compound, quite significant. And on top, if we take the super VIP installation, we are even 50% less expensive. And also due to the material we use, we have new possibilities to design the containers in different ways. So now about the opportunity we are presenting here right now, which means this is the first test case we would like to build in 2 locations. One is Germany, maybe Wittenberge, and the other one can be in Israel, which means that we have 2 different climate zones and can really perform concrete measurements about the energy consumption of the containers. We think we can build that one within 6 to 12 months, 12 months maximum. And the benefit is, of course, once we have just built one of those containers, we can enter the market and build first traction in the market and generate first turnovers. And this is just the first step to access the market with around about 100 billion euros annually. That's it. Thank you very much. Don't forget the barcode.
So hello everyone. We have the presentation ready? As most of you know, in today's rapidly urbanizing environment, buildings and construction have accounted for more than a third of global CO2 emissions in 2021. And in general, buildings use about half of their energy to maintain their internal climates, meaning to keep them cool at summer and warm in winter and cold environments. Now, this is putting increasing pressure on the construction industry to improve energy efficiency and find new materials that will enable them to do so. At Superpolymer, we address this by utilizing the unique properties of highly crystalline polymers to create coatings, on one hand, that are reflective and cooling, turning away sunlight, and enabling us to keep buildings, the inside of them, cool by as much as 11 degrees. The same material, when used differently, can be formulated and made into highly insulating and versatile coatings, which have a thermal conductivity coefficient roughly the same as expanded polystyrene. In both cases, the coatings benefit from Superpolymer's high strength and durability and resistance to moisture. In order to demonstrate the potential of Superpolymer-based coatings, we envisioned the pilot plan here in Israel to be one wall, sun-litten, of a room or a space that we will coat with a standard Superpolymer-based acrylic coating, or basically schlicht. We will monitor the temperature and energy consumption required to keep that room at a desired temperature and compare it with a reference room that is coated with standard schlicht, thereby showing the effect of cooling under sunlight. In respect to the German pilot site, there are many different pilot sites, buildings that we need to address, but in general, the thought is coating a room or a space from the inside with a Superpolymer-based insulating coating, and again measuring the amount of energy required to keep it warm, thereby showing the effect. Now, in both cases, pilot sites stand to gain, first and foremost, improved living conditions, from improved thermal regulation that will translate into energy savings, as well as increased durability of the coatings and underlying construction that manifests as savings in material terms. Both of them can be translated into CO2 savings, carbon emission. Now, as we move towards the pilot, there are several hurdles, potential hurdles, that we want to address. First and foremost, Superpolymer-based acrylic coating, in the first example, is based on an existing coating with slight modifications, and the material itself, Superpolymer, is not toxic and not hazardous in any way. We are currently in the process of obtaining an Israeli standard for a wall coating. However, if we're not able to do that before the end of the pilot, the coating can be removed and replaced with a standard one, such as used in the construction project. Also, seeing is believing. Until we've applied the coating to a large-scale project, or at least in our case, a room or a building, it will be very difficult to demonstrate to potential customers and entities in construction that it works. And we want to build, to coat an entire wall and show the effect so we can grow in scale and maximize our impact. Now, sometimes, often, with the prototypical coatings, there is a severe limitation on the color scheme or hues that you can create. In our case, superpolymer-based acrylic coating can be colored according to a wide variety of colors that can be tailored to the needs of the particular pilot. Now, if we can't do that, it can be removed and replaced at the end of the pilot after the measurements are done. Second. No. Okay. So our cost estimate is $9,000 for the entire package, meaning materials that we produce, installation, measurement package, and the contingency of removing it in case the Tekken won't come through. Now, in the case of the German pilot site, the thermal coating will require a different type of application method. But we're ready to discuss it. We're eager to discuss it because of the different types of walls that exist. So from the moment that we decide to move forward, the coating can be ready in about 2 to 3 months. And in general, when we're speaking about production level costs, the return on investment for a single household is for the entire lifetime of the product, which is roughly 15 years, is about $3,000 to $4,000. So it's a worthwhile investment. We must remember that the prototype is a prototype. The results that we see now, the performance is bound to increase. The costs essentially will go down as we scale up. And superpolymer is a generic technology. The additive can be added into a wide variety of coatings in construction. No?
Yeah.
Okay. Okay, so last sentence. Basically, this pilot for us is the opportunity to show our effect, grow in scale, reduce costs, and make a greater impact. Thank you.
Thank you.
Thank you. Thank you, VIT21 and Superpolymer. We heard 2 presentations about insulation, which we know is definitely necessary in both climates. Any questions from the ground? We start here in Israel, and then we move to Germany, so get ready. Florian? Ziv? Yeah?
There's a microphone there next to you.
For the German company. First of all, I know the technology it's called in the past VIP. What's the difference between the old technology and this technology? And what the average cost that you supposed to sell it? Because I've been research about it, and this is the main the issue, at least in Israel. So that's my question.
Yes, that's a very good question. So the main difference to the VIP, so the vacuum insulated panel, is that a vacuum insulated panel has a medium between the 2 layers, right? So and that medium is usually very expensive to produce. So we took the idea from the thermos flask, right? This is one from the 1970s, right? And there is no material in between. It's just vacuum, right? So if you you open this. Sorry, there's hot water in there. Sorry. I apologize. Let me get okay, so I apologize. Usually it's not filled up, so but we want to demonstrate it keeps it hot for a long time. So there's no material in here, but if you try to flatten this, it just collapses, right? You cannot keep these 2 layers apart from each other. So in a round shape, that's possible. In a flat shape, that's not possible. So what we have done and where we have patents on is that we kind of, can you hold this for a second? So we have these 2 plates here. And if you put a vacuum in these plates, they will collapse. And to prevent them from collapsing, we do not put material in between, but we put some guards in here. So you see some lines in here. And these lines prevent these 2 plates from contacting each other. So now we can sack the vacuum, but still there's no material in the gap
between those plates. And that is the main difference to the vacuum insulation panel. And this is why this is kind of, a technique you cannot buy at the moment. And now coming to the cost. The cost is at the moment similar to the vacuum insulation panel, because we have to carefully produce those and weld those, and this is out of stainless steel. But there's a roadmap for us. From right now, it's like 150 to 200 euros per square meter, right? But there's a roadmap from us to bring this down to 20 euros per square meter. So it's still a little bit more expensive than styrofoam, but it kind of replaces 30 centimeters of styrofoam, right? With this thickness replaces 30 centimeters of styrofoam. So you really gain space, living space. So that would most potentially justify that that's a little bit more in cost, but it has the potential to be less expensive than the vacuum ventilation panels, so the VIP panel so far.
So thank you for the elaborate answer, and maybe Germany, do you want to ask another question?
May I ask another question, if you don't mind? What is the material you are using?
So
is it
this
a
is
sustainable material?
Yes, this is stainless steel. So these plates, this is the material we use, and then we go to the big plate. So this shows the working principle. And this is now the ready element, right? Now it's closed, right? So you see the corners are here closed out of stainless steels. It has a thickness of 0.3 millimeters, so it's very thin, thin stainless steel. In there, there's only the vacuum and these cords here. Dynamo or some cords you use for the parachute people use that as very strong cords. And that's all material there. So you can fully recycle this stainless steel, right, by melting it and reusing it once the lifetime of the building is over. So there's no bio-based, fossil fuel-based styrofoam or anything like that in there. It's just the stainless steel. And the absence of air, basically, it's vacuum in there.
Thank you. Ziv, we can continue and later on. We have a very long evening. I'm happy to hear. So we go now with three companies from this room.
I have a question for the Israeli.
No, we do it later because we are tight on schedule and we have a lot more interesting companies to come.
Sorry. So we go on with three Israelis company. We start with Sela Studio, then Atom, and Eva will finish this round. Thank you. Rafael. Okay, Atom will start and then Rafael will join. Here Rafael.
So hi, I'm Rafael Fogel. I'm an architect and I'm the founder of Sela Studio. We're just going to wait a second for the presentation to load.
I'm taking it off from your time. Yeah.
Okay, so this is me. We went through that. So Sela Studio leverages computational design and robotic fabrication to create one-of-a-kind architectural installations. We explore the aesthetic and ecological potential of digital designs. We process AAC blocks individually, and they can then be attached to walls or combined to form standalone structures. We want to see walls come to life. Our vision is to conduct ecological ecopuncture in cities around the world and create miniature ecosystems that showcase an alternative future where architecture and nature coexist. We want to educate and shift mindsets towards more bio-inclusive cities, and we will do so one wall at a time. The problem, we lack solutions for promoting biodiversity in dense urban areas. The way we build and the architectural surfaces we create simply don't make space for other life forms. The solution we propose is using the latest computational software in combination with industrial robots to mill complex shapes out of building blocks. By increasing areas and by increasing surface area and introducing cracks, nooks, and cavities, we create niches that can facilitate life. So far, we've only created decorative installations, but the aim for this pilot is to create an ecological installation to assess its performance and to provide proof of concept. At the moment, we have smaller experiments in the field that primarily test for vegetational growth in different conditions, but we are looking to set up a full-scale installation that integrates within an existing building and tests for both plant and animal establishment. In terms of site, we're looking for an outdoor setting, one that has access to water for irrigation and drainage, and somewhere that is visible to the public on the one hand, but on the other does not risk being damaged by large crowds or the moving of goods. And we want to cover an area of between 10 and 15 square meters. The stages of the pilot contain design, fabrication, installation, and monitoring. In terms of the design, we could finalize it by the end of January. We already have a list of modeled features that cater to the specific needs of different species categories, but we would also like to work with our client and customize our design visually to a given project or brief. Fabrication will be carried out in February in our Tel Aviv facility, and parts will be shipped to site where individual components will be assembled, and this can take for up to a week in the beginning of March. Finally, we will conduct monitoring. Ecological sampling will be carried out once per season for the duration of a year. The budget we would require for the pilot is 56,000 shekels, and that includes materials, labor assistance, shipping, as well as professional services of an ecologist and a structural engineer. And the budget also contains the dismantling of the installation. In terms of expected outcomes, so we hope that with time, our installation will become vegetated and that some animal species will establish within. We hope to gain both proof of concept and a more nuanced understanding of the mechanisms at work. Finally, we want to create something that is beautiful, and we hope our installation can communicate a positive message and an optimistic message about the power of innovation and nature to heal our cities and the Western Negev. Thank you for your time.
Thank you, Rafael. So we have the possibility to ask 2 questions, but the answer, Rafael, stay with us, should be 30 seconds at most. Okay? Challenge, another challenge. So are there any questions? No questions? Maybe in Germany? No questions. Yes, please. You answer.
I just wanted to ask how you create the shapes, because I saw like a big drill that do you 3D print concrete also?
I do 5-axis milling with an industrial robot, and the material I'm currently focusing on is autoclaved aerated concrete, which is like cellular concrete.
Okay, any other questions from Germany? No. Yes, one more may I address the German one? And maybe after we can address you. Yes, please. Okay, so... אוקיי, אז תעשו אנדנדינו, מהר. יהיה אחרי זה הזדמנות לדבר איתם גם. אז את היית ראשונה, סליחה. אוקיי.
So it's an existing building material. It's eating blocks, and they have a good thermal value. there might be additional benefits to it, perhaps a wall that is also vegetated and somewhat wet can have some kind of micro cooling effect, but it's not something that I can currently prove in any way. But it's something that we hope to see in the experiment.
So, לא, אחר כך אני מצטערת, אני פשוט... לך? כן, לא, להם היה שאלה לגבי פרויקט אחר, הקודם. So, Tom from Atom, yes? Please.
Okay, so my name is Tom, 31, civil engineer, and I'll be representing Atom Construction under construction. Where should I point it? Okay, we don't have a lot of time, but the most important thing in every startup is the team. So Yoav and Or are the genius behind the tech. Amir, Tomer, and I are the workers behind civil engineering. When I was a project engineer in one of the largest general contractors in Israel, I've seen how much the manual supervision leads to reconstruction, then to reconstruction costs, and in the end, in delay of delivery the projects. So this is the problem we are solving. Execution errors lead to costly reworks and project delays. Of course, we handle also in safety, and you see it in a minute. So what is our solution? Our ICP is general contractor, okay? And Atom is a supervision software for general contractors. Of course, like any other startup, the solution is automation, and our value proposition is to save 5 to 10% from project budgets by the fact you build one time. Okay, so what do we see here? We developed a method of CMC, crane-mounted cameras connected to solar panels and routers on the crane. No human intervention needed. We scan the site 24/7 for the structural phase, concrete, steel, and MEP systems. Our ICP received every day PPC, not PPC we know, pre-pour checklist. Before the pour, he knows that everything is being done right. Here you can see our application. We have paying customers in Israel, and in the very near future, we're about to start project in Singapore with BCA and in United States. So this is site insights. You get 1 millimeter accuracy about the diameter, of course, centimeter resolution about MEP systems. And here you can see our safety PPE detection. If a worker doesn't wear helmet or vest, busted. We are the police. And if a worker go under an heavy load, busted, we help you save your life. So I say it again, we help our customers to save 5 to 10% from the project budget. Okay, our ICP. I heard one time a very good tip, and since then I take it. Narrow the market where you have the competitive advantage is the key. So general contractor who build reinforced concrete, not only steel, they they are self-performed concrete, and minimum project is 20,000 square meter, and the project has contained tower crane because we don't use drones anymore. And in this pilot, we are about to do a joint pilot with Metsudot that's about to start in, I think, a year and a half, hopefully. And about ESG, okay? Very simple. We help to reduce rework and waste of materials. About social, we enhance worker safety in construction site. And about governance, we have data-driven decision-making and transparency and accountability. Think about it. There is no one building or structure in the world today that you know that is built. Every rebar, every plumbing pipe, only there is planned. This is a game-changing method. Real quick, what we did here, we've seen a contractor that put diameter 16 instead of diameter 12. It's a lot of money. It's okay. And thank you very much.
תישאר איתי רגע. One question from Germany or Israel? Okay, no questions? Yes, please. They have one too as well. Please do, and then. No, you started, please, and then he has 30 seconds anyway for twice.
You're using cameras, right? So you need already existing.
Excuse me, Florian. I just have to stop you 1 second. Oh, maybe he can start and then you will, yes, Florian. So please start and then we will continue here because there is a microphone gap. Please, Florian.
What is the minimum visibility that you need for your solutions? Because in Germany you have regulations until which visibility crane operation is allowed on German construction sites, especially during winter, where you can have bad visibility, fog, rain, whatever. So at a certain step of visibility, there is no crane performance allowed anymore in Germany. So what are your minimum requirements regarding visibility for your solution?
Thank you very much. It's a good question. So I'll take it to two. First thing, think about it, that you can see and operate whatever the crane operator see. And since we pivoted from drones to crane-mounted camera, we have like, I don't know how to say it in English, the visher, the one you do for the rain. So we, now in January, we had a few days of rain and it's okay. We didn't do a pilot yet in Alaska, but it's in our roadmap for 25.
I think he got the answer from...
Okay, great. So do Adiel, רוצה לשאול משהו? אני רק אחזור על השאלה כי הם לא שומעים אותה בגרמניה. מה את רוצה לשאול? So the competitive landscape, he's been asked about that. 30 seconds.
So there are in the market great companies like SiteAware, Israeli company, TopDeck AI, and many more. Our competitive advantage is the 1 millimeter accuracy. We bring rebar detection. Second thing, we don't demand anything from the site team. No drone operator, not go with cameras. Once you start work with us, leave it on us. And the third thing, that we bring live view 24/7. Think about it when we did with drones, which are most of the other solution, you have like dots in the space. We bring the full picture. Okay.
So, do we go for it? Forever, yes, Eva. Please, the last, or not the last, but one of another company from Israel. Thank you, Tom.
Hi everyone, I'm Jacob. I'm the head of operations and finance at Eva Green Tech. And we'll get started when this is up. Might as well start now before the time starts ticking. What is the problem that Eva is trying to solve? We are in the concrete business, the cement business broadly speaking, and the problem that Eva tries to solve is the carbon footprint of concrete. So concrete accounts for about 8% of total global CO2 emissions, which is a lot. And we are in the midst of the largest wave of building growth in human history. So it's a problem which is not going away anytime soon. EVA's mission is to take construction and demolition waste, which is basically what you get when you knock down old buildings, bridges, infrastructure, stuff like that, and turn it into high-quality building material, which can partially replace the cement and concrete mixes and can help to address this carbon problem and also generate new profits for the industry so that it can be actually sustainable and scalable and have a real impact. Quick primer on concrete. So concrete is the second most consumed material by humankind after only water. Cement is basically the glue. It's the binder. It's the most expensive part, the most high-tech part, also the most polluting part, and that's what we're working with. So EVA's technology takes this construction and demolition waste and turns it into what's called supplementary cementitious material. Big name, this is basically material which is very similar to cement. It's already a $30–40 billion industry today. Why is it such a big industry? Because it's cheaper than cement and it has a lower carbon footprint. But this is an industry which is growing a lot. And the reason for that is because the demand for this type of material is way, way, way bigger than the supply. And that gap is getting bigger and bigger every year. And there are reasons for that. Basically, the supply is going down and the demand is going up. We can talk more about why later if anyone's curious. But so this is a market which is going towards $80–120 billion in the coming years. And because of this big gap, there's really a blue ocean for EVA and other companies to compete in. So a little bit about what we've achieved so far. We've raised money. We've raised about $1 million. We've done successful validation tests. We have patents pending. We've done accelerators like Under Construction, also with Holcim, which is one of the largest cement companies in the world. And perhaps most importantly, we've actually deployed our material, or I should say a concrete company has used our material in a real load-bearing project, which was a very big vote of confidence in the viability of the technology. And so what's next for EVA? Basically, we've shown that the technology works. So the next step is to show that it can be mechanized efficiently and effectively. It can be done at scale. And the way we're going to do that is by building a demo site, a pilot production unit. Now, we're already in conversations with a few potential partners, both in Israel and in Europe, to do this. If anyone is curious to speak with us about that, please do reach out in any capacity. And we're hoping to get started on that in the coming months. There are some things we can do to accelerate that process to generate more and more interest by our potential partners. Among those things are offtake agreements. So this would be, right now we're producing a material at lab scale, but once we have this production unit in place, we'll be able to produce more of it. And so if we can sign some offtake agreements, that can help basically generate interest and de-risk the investment that's necessary to build this initial plant. And we've already had some good conversations with Florian from the German site, if Florian can hear us, about that for some of their flooring. But if anyone else has basically any concrete that you're using in any of your projects that you're going to still be pouring in 18 months, please do get in touch with us. In terms of pricing, where the pricing will change as we mature, but right now we can commit to about 150 euros a ton. I think that's what we told Florian. Basically competitive with cement prices. So I would say think about this as something which will not actually change your cost structure of your budget too much. And the last thing that we've thought about, which is more relevant to the Israeli sites, which is something that we could do basically by preparing our material in our lab and we could get started on right away, would be something symbolic, a small sort of art piece, let's say. Essentially, what we were thinking of was taking something that had been destroyed and making something new out of it with this technology, turning into this new cementitious material and making something new out of it. And that's something that we would contribute. So if anyone is, any of the sites here from Israel would be interested in talking about that, we would be really excited to explore that. Yeah, and I'll wrap up there if anyone has any questions. Also, I should say we are in the midst of raising our seed round. We've raised most of it, but not all of it. So our CEO, Tamar, is in the audience. If anyone is interested in speaking about that, please do get in touch.
Any questions? I have a question. Sorry that I'm the mean guy. But how you trying to solve the problem when you demolished a building with the gypsum boards and the concrete floors or
Sure.
ceilings. How you gonna, because I know when you put the two materials in one place, there is degradation and all kinds of things that happens to the last material. So how are you gonna solve that?
I won't speak about the super technical level because I'm the business person. But what I will say is that basically all of the developed world, construction and demolition waste is all sent to specialized recycling facilities, and it's separated by them already. So part of what EVA does is it taps into this existing supply chain. So they're already taking out basically most of the stuff that we don't want in the material for us.
So you get it clean?
Yeah, more or less, yeah.
Okay. Thank you.
Excellent.
Yes. Thank you, Eva. So yeah, we're just about more than half already done. So
yeah,
yeah.
And now we're gonna have a presentation of ferric CO2, and after we will hear from Germany Vireo Fibers, two concrete projects once again. So Ilan, please join us. And please note that afterwards there's some demo presentation of Ilan outside, so you can reach it.
Hello everybody, my name is Ilan from Trick CO2, and this is the proposal. We aim to provide low carbon footprint products using CO2 captured, and to market it at a low price below the current when producing scale. ESG regulation, current and the future, will require us to reduce the CO2 emissions. So this is the future. So how do we do it? CO2 is the major greenhouse gas emitted by humanity, and my startup is going to turn it into raw materials for the construction sector. CO2 is addressing climate change both directly by capturing CO2 and by producing low carbon footprint building materials. So the process involves moving air through the machines that has absorbing sorbent. They convert the CO2 into carbonates. The resulting materials is encapsulated into capsules, and then the capsules go into the building materials, reducing the amount of concrete. So this is the sorbents. There are two types of sorbents. They are hydroxide-based. This is the example of low carbon footprint building materials. It can be shaped in any shape required. You can see here how the material, the carbonated material, is encapsulated in it. So the pilot that I propose is making 30 square meters of interlocking bricks using CO2 capture from the site and cleaning the CO2 from the air during the process. A warehouse of 100 square meters is needed with access to water and electricity. Half of it will be used for CO2 capture, and half of it for the making of the building materials. So this is the Model 8 CO2 capture. The plan is to make two machines, two enhanced Model 8 machines with 4 times the capacity. So the cost estimate is 6,000 shekels, which I will cover. The end product is interlocking bricks for decorative and outside use. The inside is made from CO2 capture at the site, reducing the amount of concrete by 40%. Estimate cost is 3,300 for 30 square meters. Same price as the market with a 5 years warranty. Timelines. So 1 month from start, we will build the CO2 capture and accumulate the carbonated solvents. 3 months from start, we will deliver 5 square meters of interlocking bricks to be tested in real life. 6 months from start, we deliver 25 square meters. And that's the end. Thank you.
Thank you, Ilan. Any questions, maybe from the sides or from the floor?
Do you have a live example of the material you created? Yeah, it's a side. Just show us. People can see it.
So while Ilan is going to bring his examples, any questions? Florian?
So you can see here the bricks inside the carbonated solvents.
So basically it can look in any shape, any size, and just less material inside, less polluting material.
Yeah, less concrete.
And when you, for example, break the brick or it's released back, or
no, it stays.
Why don't we repeat the question?
Well, for example, if you build a building out of these bricks and you want to knock it down, and how do you separate then the concrete? You heard about recycling concrete and the...
So just for our friends in Germany, the gentleman asked about how we can separate the two materials and the life cycle of the process.
Okay, so you can break it down when it's at the end of life, and you reuse it again. And it won't release the CO2 unless it's exposed to strong acid or higher temperature.
Is it reinforced concrete?
No, it's totally reinforced. It's just the capsule provides the strength. You can be shaped the capsule itself to remain strong as it was before.
Thank you, Ilan, and our friends from the Vireo is already ready.
I don't know if you can hear me, but it's my question was the calcium hydroxide sorbent that absorbs the carbon dioxide. What is its origin? What is it derived from, the hydroxide that you mentioned?
It's based on sodium hydroxide.
Sodium hydroxide. Okay.
And it's you can hear me?
Yeah.
Okay, so it's sodium hydroxide based, and the production of sodium hydroxide is made by hydroelectric energy, which is green.
Okay, thank you.
And now it's time for Vireo.
Yet still, I'm delighted to be here today to present to you what Vireo Fiber does and how we can help reconstruct the kibbutz. To start things off with, I would like to tell you a quick personal story of how I got here. And it was basically a visit of, well, I was visiting a friend in Tel Aviv. And while walking the streets of Tel Aviv, I have noticed all the brown smears on the wall that come from the corrosion of the steel inside those walls. And I think anyone that's ever been to Tel Aviv knows those sites very well. And me having a background in material engineering, I knew there was better building materials out there. And upon closer inspection of the current state of the Israeli construction market, I have identified a few key and unique challenges to Israel, which I believe I can tackle with the material that that I have.
Ist noch gar nicht, Bildschirm ist noch gar nicht geteilt.
Ach so, mein Bildschirm. Oh, sorry. Ah. Sorry, technical difficulties.
So.
Okay. Sorry, now we're back. Excuse me, I'm a little bit sick, but I hope you can hear me anyway. So where was I? The Israeli houses and the Israeli construction sector have quite some unique challenges, namely the corrosion of the steel inside the walls. And this means houses have to be renovated, they have to be torn down, and they are not as structurally sound as they could be. And on top of that, because of the current situation, there's also less workforce in Israel, and Israel needs to build quickly. So I have found a product, a technical innovation that I believe can tackle these challenges. And what I do with Vireo Fibers is bringing this innovative material to Israel. And what it is essentially a replacement for the steel inside the concrete. So instead of building houses out of steel and concrete, we can now build them out of carbon fiber. And because the carbon fiber is so much stronger than the steel, a wall that's traditionally 40 centimeters thick can be made to be 5 centimeters thick while holding the same load. And this means you need 80% less concrete, you need to transport 80% less concrete to the construction site, and you need less equipment to pump it up. On top of that, you have a faster project completion time because less concrete needs to cure, and you have a reduction in labor costs. And because this material does not corrode, you also increase the lifetime of those houses significantly. Now, to show you how that works practically, on the left-hand side, you see a rebar, so like a steel reinforced slab, and on the right-hand side, a carbon fiber reinforced slab. And in a side-by-side comparison, the advantages become obvious. On the left-hand side, an old traditional beam, and on the right-hand side, a new carbon fiber beam. And you can see that you use a lot less material to do so. So the question is, where are we now and what is my offering? Me or my company, Vireo Fibers, has a strategic supplier for this material, and I'm providing planning and consultation services, as well as supplying this material and facilitating the implementation in Israel with trained personnel. And this is possible because at the beginning of this year, we got in the EU a general approval to build any new construction with this material. And now, to jump the gap, we need to translate this into the Israeli market. I can use this material now on an individual basis, but as an entrepreneur, I want to have a general approval in order to really roll out into the market. And this is where I need to bridge a gap. But in regards to the kibbutz, there's already so much we can do right now. And I was being provided with a list of what needs to be repaired or newly built in the kibbutz Kerem Shalom. And let me tell you, I can almost build any of those projects with my material, but in particular, the new cow barn construction and the repair of cracks inside residential homes stood out. And they stood out to me because we have done these things in the past. This is a renovation of an industrial floor. Actually, this is the factory of the supplier I'm working with. And this would be an ideal use case for the floor of the cow barn because my material is alkali resistant. So that means the droppings of the cows, as well as the chemicals that you use to disinfect it, will not attack the concrete. And that means they will not attack the steel in the concrete. And that effectively means when you build a floor like this, it's going to last twice as long, and you can build it almost 3 times as fast. So that's something that I really want to do in the context of my project. As well as the renovation and the repair of cracks, that's a very straightforward process. You scrape off the old concrete, you put a layer of reinforcement there, and add a new layer of concrete. And using our material, that can be done very quickly. In a side-by-side comparison of a 5 square meter wall, it took 34 minutes with our material and for almost 5 hours with a traditional material, just because you have less concrete that needs to cure. And we can also build water tanks. We can use it in new constructions. All of these projects are built using our material. And this is why I kind of want to stop looking at the time. Main advantages of this material is up to 80% of CO2 saved. You double the lifetime of buildings, you can build them quicker, and you need less labor. And if this sounds too good to be true, and it does sound too good to be true, let me tell you, it's really not. And I have 15 years of academic research backing this statement up. I would love to take this conversation offline if someone is interested, because there's more to tell about company building, but in the context of the kibbutz, I want to do the floor of the Kauvan and repair the cracks inside the house.
Thank you, Konstantin.
This is where I want to end. Yes.
Any comments, questions? Yes, Tom.
Can you hear me?
Yes.
Yes, okay. You have mentioned that it's allowed to use in Europe. My question is if it's allowed in any construction site, like 20 floor, or it's allowed under the EN standard for renovation or some part to replace the steel, the rebars.
So regulation is not just one thing. There's many of those. At the beginning of the year, there was an approval for new construction. What this material is currently mainly being used for is bridges, tunnels, roads, as well as for renovation. The landscape of regulation within renovation is very small and very, very limited. There is not so much. But for new construction, that is a lot more heavily regulated. And we got an approval to use it within Germany for any type of new construction. And over the next 3 to 5 years, this is going to be translated into the Eurocode, which is an EU-wide building regulation on new construction regarding steel, concrete, and alternatives of steel concrete.
Thank you, Konstantin. Sharon, you want to ask something? Here.
Hi, my name is Sharon. I'm the head of the supervision company in Kerem Shalom. And first of all, be well. You look sick. Second thing, please, you're more than welcome in Kerem Shalom. We have a lot of cracks. Many of them are because actually a lot of rockets over there. And most of the apartments there are fully of cracks. And I believe that we can have a nice joint venture there. Just we need to have a pilot. We will see the material, we see the implementation, we will see all the detailing of what you are doing. And what is my concern is what is the strength of tension, because there's a lot of tension over there now, because of their new places, new houses, connected to an old houses. For example, security rooms, like shelters that connected to the houses. The shelters are new, and the existing ones are very old, from the 80s, from the 90s. So the crack is there.
Yeah.
Okay?
Okay. So in that way, and I will collaborate with my engineering team on this, what you need to do is essentially you need to scrape off the concrete until you reach the structural layer, and then you integrate my material, because otherwise we can put it on top, sure, but it's like there's no inherent tensile strength within the wall without the reinforcement material. So what we need to do, and I can go back to my presentation.
Unfortunately, I have to, like, you can just finish your answer and then
Scraping
we get
it
to
off?
together. Yes.
Scraping it off, putting new reinforcement materials on there, and then the new concrete. I would love to do that. And honestly, if you tell me this is what you want to do, I will pack my suitcase full of it and I will fly over and do it myself. And I'm being serious about it. Okay. I think that's a good way to end, right?
So thank you so much. You excited us, and this was our vision. So to have matches like that, so a dream come true. So thank you so much for being here, Sharon, and thank you for presenting this. Now we have our last final twos. No spoiler, but they're really exciting. So stay tuned, and please, Soft Lab.
Good evening. So we're Soft Lab. We are Soft Lab, so Shanit, Alon, and Liran. Wait, no. Okay, so we wish to tackle two focal issues of two different industries. The first industry is the textile industry, and this industry emits 92 million tons of textile waste. There are issues of obviously gas emissions, high water usage, and also processes of dyeing and coloring, which affect greatly the landscape in certain cities and areas in the world. The other way to talk about it is to think of the impact of it by imagining 4 buildings of the Berlin TV Tower filled with textile every day, or the Empire State Building filled every day, or the Buckingham Palace filled every day. So this is just a way to imagine the scale. The other industry is the construction industry, which is obviously, as stated before, in charge of almost 40% of gas emissions. So another way to imagine impact is thinking of a 100 square meter apartment which is constructed, which is responsible for 20 tons of construction waste. So obviously this waste ends its life after one cycle, most of it, or half of it, big parts of it. And what we want to do is imagine the connection between these two industries, so turning textile waste or upcycling textile waste into building materials. The process in large is, first of all, collecting. We have partners and NPOs and people and organizations that store those textiles and arrange them. This is the part of collecting. Later disassembling and using it as elements, which could be later fabricated and constructed, also arranged. And then upcycling it in certain methods that we are developing in the lab into sheets, elements, blocks, basically building materials. So what we want to propose this evening for this pilot is lightweight, easy to transport and DIY-friendly building envelope or partition, which this is what you see here is a mock-up that was built and was developed in the lab. And this is another part of the development from new shredded sheets of textile waste. We want to harness climatic and environmental qualities that are inherent in textiles, so we want to reduce our dependency on machines, on air conditionings. We also want to think about local production, local fabrication, less transportation, so everything is happening in the same local area that it's built. So collecting textile could be anywhere in the world. Fabricating also could be on site, and thereby reducing the need for transportation, simplifying fabrication process. Our system eventually is an idea of using an element that is lightweight that gets into an existing structure, and could be adaptable for certain needs. It's sort of a DIY system that could be changed according to client spaces and programs. We thought about two sites. The first one is Nir Yitzhak. This is a dining room. It's a big concrete shell, so it's hard architecture, and we want to introduce our part, the soft architecture. There is already a process of using textiles here. You can see the curtains, which are regular curtains, but they're here to rearrange the space and arrange different meetings or different programs. We want to use this site as a pilot and offer the idea of maybe 20-ish square meter surface of the element, the architecture, the soft element, which is a partition, but also sort of a communal work or a communal project. The idea is that this is going to be with the involvement of your community in thinking, designing, and possibly later also fabricating, because potentially using methods that were developed in the lab of reusing the textile. So just quickly talking about timeline, 12 weeks. 8 weeks of design, then 3 weeks of fabrication, 1 week installation. The other side, which obviously we thought is a good fit, is the place where it all began. So the factory, ground zero, the factory for the sewing machines. So Zinger is a known and very big and famous factory for the sewing machines, which could be regarded as a main or general building block for the textile industry. From the act of sewing, we wanted to take one space there, and instead of seeing the textile finishing its life after one cycle, we want to say, okay, there are more cycles, 20 more seconds. So a bigger element, 60 square meters. Obviously, this one is going to be more based on material research, so development of materials that are going on in the lab. We're talking about 8 to 9 months, so 5 months of material development, heat and insulation, durability, and also how it performs, the material itself. Later, 8 weeks of design, 4 weeks fabrication, 1 week installation. We want to field test it. We want to see the client collaboration and see how we can adapt with their needs. We want to check the scalability with this pilot. We want to further develop our aesthetic qualities. And also, we want to see how it can adapt to changing needs and programs. Just one word to finish. We're Soft Lab. It's a design-led research lab in Bezalel Academy of Arts and Design. We're textile designers and architects. And one last thing to say, that we just now got a big grant from the government to develop 2 years of research for our prototypes and materials.
Questions? Okay, no questions? Here, Florian?
Not a question, that's like a big invitation to come to Wittenberg and just have a look, because I think it's really like a fit. Textile blocks, and using insulation. Really interested in hearing more, so let's get in touch about this one.
Let's do it.
Yeah. Okay, another match. I think the third time you go to heaven, no? Something like that. Anyway, the last one is from Germany as well. We're very excited to present Baukreise. Are you there?
So hello everyone, I hope you're not too tired, and I promise to not keep you much longer than the 5 minutes I'm allowed to, but I hope you're still open to hear about this topic because it's hot. And the topic I want to talk to you about is the topic of upgrading windows instead of replacing them. And why is this a hot topic? Because literally through our windows, we are heating the planet, and this costs us in Germany over 4 billion euros. And in terms of CO2, it's nearly 9 billion kilograms of CO2 that we literally throw out of the windows. And why do we do this at a personal level? Because replacing the windows by new windows is not cost efficient. Windows are a product with a 30-year life cycle, and the cost of it means that the first 24 years of the replacement, you're not saving any money. You're saving money on the last 6 years. And in terms of CO2, it's not as bad, but also not as good, because the ROI of the CO2 investment of a new window is also very low. The solution we propose aims to reach an ROI of 10 years from a financial perspective and has only a fraction of the CO2 impact, because we use basically everything of the existing window and just add the necessary layers to make it better insulated. How this works is 2 parts. There's a topic of upgrading the frame, so insulating the frame of the window. which only affects 25% of windows. Most of them that need an upgrade have a good frame. And the second part is upgrading the glass itself. So we're basically making a window with 3 glass panes from a double glazed window. And I don't know if you can see it here, but we brought a prototype. Oh, wow, okay. And I hope you don't see anything, because that's the beauty of it. It looks like the window before, but it's now a triple glazed window and not a double glazed window. Our aim is to put this into mass production through with the help of automation and on-site production. So what we aim to do is establish a system where existing windows are measured up automatically based on an app we're developing and are refurbished on-site in microfactories. And the reason behind this approach is that we're actually offering 2 business models that are going hand in hand one with another. For building owners, we sell the product. We sell this window at a very good price point because it's much less expensive than producing a new window. At the same time, for craftspeople, we sell the factory that enables them to do these upgrades with a modular approach. And this has the background that we are looking towards a monopolistic market in the producers of windows and of double glazing. And to get a foot into the market, we need to enable people to produce these upgrades themselves. And so this dual business model has the aim to offer a product that is needed in the market and at the same time getting a foot into a market that is very monopolistic. The market we're talking about in Germany is around 4 billion euros today and is growing twice the pace as the overall building materials market. So it's already growing very faster than the average. However, this is only pushed by regulation and subsidies because, as you saw, economically, it doesn't make a lot of sense. So just imagine what we could do to that market with a product that costs much less. We're currently in our research phase and at the same time, as you see, developing our business model and a price point with which we want to get into the market. We already have quite some cold sites, as we call them, because they're based here in Germany where you want to keep the heat in. We're still open for hot sites. This would be sites where you want to keep the heat out because we believe that the system would also apply there. And as I said, our research is now fully funded and we're looking for funds to help us develop further our software and hardware needs, so the tooling to industrialize the process. And I hope some of us will join us on that road.
Thank you so much, Baukreisel. So one more question maybe before we end up. Is there any question here from the crowd or in Germany? One for Florian? No?
Who wants to?
Okay, I'll ask something, okay? So, I don't know if you see us, but the Liebling Haus here is a typical window of the 30s, which is a classic, we call it Bauhaus. It's not Bauhaus, but it's a Bauhaus window. And obviously it has a quite thick window frame, a wooden frame. Would it be possible to do something in a window as such? I don't know if you can see the window. Yeah, yes, it's just behind me, actually.
Yes. It would absolutely be possible to do it. The thick frame, the thick wooden frame is an advantage because those are the windows that don't let much in through the frame. So the thicker the wood is, the better it is from a frame perspective. And also for an upgrade of the glass, because obviously we need some space to put in the new glass module. And so if the frame is thick, that's also an advantage. So I believe we could upgrade this from probably a single glazing to a double glazing, right?
Great. So that's exactly the answer I wanted to hear. So, yes. So thank you so much to all of you. Great job. I'm so excited. Yeah. And we're about to finish. So Melina will screen the company's logos here. And now we will all vote. The vote will be a vote of us in the board, so to say, and you. And then we will decide who the winner is of the day. So the QR code, where's Melina, is to be scanned. One. Yes. Count with me. Yeah, get your phones ready and your cameras, and maybe think already who your favorite is. We have 9 companies.
How many times are we allowed to vote?
Yeah, you're not allowed to vote for yourself. We didn't take that into consideration.
Can you hear us?
Yes, we can hear you. Yeah, here you can scan, please.
We can't scan because we have no screen share.
So Melina can please send the scan.
Thanks.
I will.
Please scan. It should be possible from there.
מה זה עושה?
You see? We was counting on technology. That's what happened.
For the ones that don't have connection, you need to log into the White City Wi-Fi. Someone just asked me that there's... No, you don't, but some people don't have connection here, I guess because of the concrete walls. Yeah, 1 second. We want you to scan the QR code and then I press further on. Wait a second, that's what you're supposed to see.
Wow, I'm sorry.
Giving a lot of thumbs up.
The overload.
They can see the
Yeah. What do I vote? That's interesting.
Once again, there are 3 questions that you will soon be able to see. You will soon be able to see.
Okay, thank you.
Ich glaube eine, aber ich weiß nicht.
Do you have 1 vote?
Yes.
Yes.
All right.
Kai, 1 vote, like it's 3 questions with 1 vote, and we can hear you, Kai, so don't tell your favorites out loud.
Of course not.
So whoever doesn't have the Wi-Fi, it's White City 1 to 9. The barcode again. את הלוגוים של החברות כאילו?
Okay, we go again. V21, we saw the installation and super polymer Israeli installation. Sela Studio did the wall with the
biodiversity.
Atom take photos of the construction site. Eva reusing and better concrete. Cyric CO2 is CO2 capture and bringing it back to the building sector. Vireo Fibers is creating the concrete soft slab, soft building material, and Bauweisel the windows.
Eigentlich nicht, aber
Are we all good on the German side?
Yeah, we did already. We just wait for the next slide.
Wi-Fi is White City and 1 to 9. No? Really no.
And once again, I want to remind you that the voting is only for the prize that we will soon announce, but so once again, the prize will be announced soon, but it doesn't mean about the pilots. We are gonna talk individually with each and every one of the sites. We already heard there are 2 goes already declared, but hopefully we will find some more matches. So stay tuned with us. And here's the second question.
Okay. Can you hear us?
Yes, we can hear you.
Yes, please. Could you please explain the question?
Explain the question.
Leading the charge means who's like the most innovative out of the box, right?
Yes, innovative in terms of climate change, or how he approaches or it approaches climate change. Challenges, yeah.
Always each single time.
Somebody likes.
Well, it's a close call. Okay.
לא, הם בגרמניה.
Which found it. So, who do you want to support with your money? Yeah.
Tension is rising. Are you still there? Schon längst der Gewinner.
All right, good. Okay.
Okay. So somebody say some words. Du irgendwas machst, geht es bei mir automatisch. Oh. Ja. Ja. Wir sind schon durch mit dem. Wir haben noch ein Boot. Oh, we don't have the scan anymore. So what? Für was ist denn die Frage?
Der Sieger ist von euch, ich muss es jetzt wissen.
Also, okay.
Okay.
Ja, hast du?
So we have votes. Maybe we can show the graph again. Show the graph again. The graphs. Okay, so we have a winner. We have two winners. Wow. Okay. So we have two winners and one prize. So Realpolitik it's called, no? What do we do? Okay. our winner is Vireo Fibers. Yeehaw! Yes. And our Israeli winner
there's another one.
is, I guess it's Soft Lab. Do you calculate with me or no? 5?
No.
6? Who? Eva? Oh. No, I don't know. Oh, Soft Lab and Eva. Oh no, Eva. Okay, Eva is the Israeli prize winner. Great. So what I didn't tell you is that we have a winner of the crowd, which gets a very, very exciting present. This. Yes. That's our present for today. And we have another winner, even more exciting, which is going to be evaluated by the board. And we will do that on a later stage and let the firms who won know later who's the winner. But the prize is that whoever wins, if it's a German company or an Israeli company, gets to go to the other side. So Germans get to go to Israel, and Israelis go to Germany to pitch together with us on the demo day, which is going to be in Berlin, and another one in Tel Aviv. So this is our prize, which I think is an amazing achievement. So stay tuned to receive the winner. And Eva?
But the most important thing is to see the pilots on the ground, and hopefully we're going to see more than one. So it's really, really exciting. And this is the first take of under construction, and we look forward to stay in touch with the companies, help them, and continue this thing that we just started on. So thank you, everyone, for joining us. And you can stay for drinks and some snacks. Thank you.
Bye. Goodbye.